Hello students, how are you? I hope all of you are good. In my previous video, I completed 1 to 6 questions of the exercise 11.2. In this video, I am going to continue from the question number 7. And the question is, the Cartesian equation of the line is x minus 5 divided by 3 equal to y plus 4 divided by 7 equal to z minus 6 by 2. Then write its vector form. In this question, he has given that Cartesian equation of the line and we need to write its vector form. So, in this question, the Cartesian equation is x minus 5 divided by 3 equal to y plus 4 divided by 7 equal to z minus 6 divided by 2. To write its vector equation, first compare this equation with its Cartesian form, that is standard equation of the Cartesian equation, that is what? X minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 by c, where this line passes through the point x1, y1 and z1 and parallel to the vector whose direction ratios are a, b and c. And the corresponding vector equation of this line is r vector is equals to a vector plus lambda times of b vector, where a vector is the position vector of the point through which the required line is passing and b vector is a parallel vector or direction vector. So, to write its vector equation, first we need the a vector and b vector from the given line. So, see here, on comparing these two, the value of x1 is 5 and the value of y1 is minus 4. So, this can be written as what? Y minus of minus 4. Therefore, in place of y1 we have minus 4. Hence, the value of y1 is minus 4 and z1 is equal to what? 6, which implies the position vector of the point x1, y1, z1, that is 5 minus 4, 6 is what? A vector and its component form is 5y minus 4j plus 6k. So, we got the A vector and B vector is a parallel vector where the direction ratios of B vector in this given Cartesian equation. So, direction ratios of parallel vector B vector is what? A, B and C, where the value of A is 3. And comparing these two, value of B is 7 and the value of C is 2, which implies B vector is equals to 3i plus 7j plus 2k. So, for the required vector form of the given line, just substitute these two vectors, A vector and B vector in its vector equation. That is what? R vector is equals to A vector 5y minus 4j plus 6k plus lambda times of B vector. B vector is 3i plus 7j plus 2k, and which is a required vector form of the given line. I hope all of you understood this question. Let's start the next question. And the next question is, find the angle between the lines. R vector is equals to 2i minus 5j plus k plus lambda times of 3i plus 2j plus 6k and R vector equals to 7i minus 6j plus mu times of I plus 2j plus 2k. So, in this question he has given that two vector equations of the line and we need to find the angle between them. The formula for angle between any two lines is given by the formula for angle between the two lines when their vector equations are given. The formula for angle between two lines, angle between two lines is cos theta is equals to modulus of b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. where b1 vector is direction vector of the first line and b2 vector is direction vector of the second line. So to identify the b1 vector and b2 vector, just compare the first line and second line with their standard equation of lines, where the standard equation of the first line is r vector is equals to a1 vector plus lambda times of b1 vector, and the standard equation for the second line is r vector is equals to a2 vector plus mu times of b2 vector. So compare this first line with the first given equation of line. So in place of b1, we have 3i plus 2j plus 6k. Therefore, the direction vector of the first line is, therefore, the direction vector of the first line, that is b1 vector, is 3i plus 2j plus 6k. 3i plus 2j plus 6k. And similarly, compare this second line with the r vector is equals to a2 vector plus mu times of b2 vector. So in place of b2 vector, we have I plus 2j plus 2k. Therefore, the direction vector of the second line b2 vector is I plus 2j plus 2k. So we got the required b1 vector and b2 vector. Next, we need the required values. That is what? b1 vector dot b2 vector, magnitude of b1 vector and magnitude of b2 vector. So first, I am going to find the b1 vector dot b2 vector. So b1 vector dot b2 vector is equals to, b1 vector is 3i plus 2j plus 6k dot b2 vector is I plus 2j plus 2k. So hence the vector b1 vector dot b2 vector, dot product of two vectors obtained by multiplying the corresponding coefficients of I, j and k. So in the first vector, coefficient of I is 3 and the second vector coefficient of I is 1. Therefore 3 into 1, 3, plus coefficient of z 2 into 2, 4, plus coefficient of k 6 into 2, 12, which is equals to 12 plus 4, 16, 16 plus 3 is 19. Therefore b1 vector dot b2 vector is 19. And similarly, we need what? Magnitude of b1 vector and magnitude of b2 vector. So magnitude of b1 vector is equals to square of the I coefficient, that is 3 square, 3 square is 9, plus square of the j coefficient, that is 2 square, 2 square is 4, plus square of the k coefficient, that is 6 square, which is equals to 36, which is equals to 36 plus 4, 40, 40 plus 9 is 49. Therefore, magnitude of b1 vector is square root of 49, and which is equals to 7. Similarly, magnitude of b2 vector is equals to square of the I coefficient, that is 1 square, 1, plus square of j coefficient, 2 square, 4, plus square of k coefficient, 2 square, 4, which is equals to square root of 4 plus 4, 8, 8 plus 1, 9. Hence, magnitude of b2 vector is equals to 3. To identify the angle between the given lines, just use these three values in the formula. So therefore, angle between the vectors b1 and b2, or angle between the two lines cos theta is equals to modulus of b1 vector dot b2 vector is 19 divide by magnitude of b1 vector is 7 into magnitude of b2 vector is 3. Therefore, cos theta is equals to 19 divided by 7 into 3 is 21. Hence, angle between the two lines theta is equals to cos inverse of 19 divided by 21. I hope all of you understood this question. And this question is an important question. Many times asked in your annual examination for 2 marks. I hope all of you understood. Now let's start the next question. And the next question is, find the angle between the lines. So in this question also we need to identify the angle between the given lines, where the first line is r vector equals to 3i plus j minus 2k plus lambda times of I minus j minus 2k. So by comparing the first line with its standard form, we got the b1 vector. Here the b1 vector is I minus j minus 2k, I minus j minus 2k. And b2 vector, compare this second line with the standard equation of line. So b2 vector is equals to 3i minus 5j minus 4k. 3i minus 5j minus 4k. So now we know the formula for angle between two lines. That is what? Cos theta is equals to modulus of b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. So to identify the angle between given lines, we need b1 vector dot b2 vector, magnitude of b1 vector and magnitude of b2 vector. So firstly, b1 vector dot b2 vector, which is equals to, as you know that dot product of two vectors obtained by multiplying the coefficients of I with I, j with j and k with k. Therefore 1 into 3 and then minus 1 into minus 5. First thing, minus into minus plus 1 into 5 and then minus into minus plus 2 into 4 is 8. Therefore b1 vector dot b2 vector is equals to 3 plus 5 8, 8 plus 8 is equals to 16. So we got b1 vector dot b2 vector, and then we need the magnitude of b1 vector. Magnitude of b1 vector is equals to square of I coefficient 1 square 1 plus square of j coefficient minus 1 square is also 1 plus square of k coefficient minus 2 square is 4, which is equals to square root of 6. And magnitude of b2 vector is equals to square of I coefficient 3 square 9 plus square of j coefficient minus 5 square is 25 plus square of k coefficient minus 4 square is 16, which is equals to square root of, so 16 plus 9 25, 25 plus 25 is 50. Therefore 50 can be written as 25 into 2. Therefore square root of 25 is 5 into root 2. So therefore root 50 can be written as 5 root 2. So we got the required value. Just substitute these three values in the formula. So therefore cos theta is equals to modulus of b1 vector dot b2 vector is 16 divided by magnitude of b1 vector is root 6 into magnitude of b2 vector is 5 root 2. Therefore cos theta is equals to, see here 16 can be written as 8 into 2 divided by root 6 can be written as root 3 into root 2 into 5 root 2 as it is. So therefore cos theta is equals to, see here in denominator we have root 2 into root 2. So root 2 into root 2 is root 2 whole square. Here square root square get cancelled, which is equals to 2. It means from numerator and denominator we may cancel 2. 2 and root 2 into root 2 is also 2. Therefore 2 and 2 get cancelled from the numerator and denominator. Remaining 8 divided by 5 root 3. Therefore angle between the two lines theta is equals to cos inverse of 8 divided by 5 root 3 is the answer. I hope all of you understood this question. So let's start the next question. And the next question is, find the angle between the lines. So in this question also we need to identify the angle between the lines. But here he has given that Cartesian equations of the line. So as you know that the Cartesian equations of the line is x minus x1 divided by a1, y minus y1 divided by b1, z minus z1 divided by c1. So this is a first line, and second line equation is x minus x2 divided by a2 equal to y minus y2 divided by b2 equal to z minus z2 by c2. So in the first line, A1, B1, C1 are the direction ratios of the direction vector of the line. It means here the parallel vector or direction vector of this first line is, that is B1 vector, which is equals to A1I plus B1J plus C1K. Similarly, the direction vector for the second line, that is B2 vector, is A2I plus B2J plus C2K. So for angle between two lines, we need B1 vector and B2 vector. So for that, just compare the given two lines with the standard form of equations of lines. Directly we got B1 vector and B2 vector. So see here, by comparing the first line with this first line, first given line with this first line. Value of A1 is 2 and the value of B1 is 5 and the value of C1 is minus 3. And similarly, by comparing second given line with this standard form of line, that is what? A2 is equals to minus 1 and B2 is equals to 8 and C2 is equals to 4. Therefore, from the first line we got B1 vector. So B1 vector is A1I plus B1J plus C1K. It means 2I plus 5J minus 3K. Similarly, B2 vector is A2I plus B2J plus C2K. Here A2, B2, C2 are minus 1, 8, 4. Therefore, B2 vector is minus 1I plus 8J plus 4. I hope all of you understood. Now just substitute the required value in the angle between two lines. That is what? Cos theta is modulus of B1 vector dot B2 vector divided by magnitude of B1 vector into magnitude of B2 vector. So we need B1 vector dot B2 vector. So therefore, B1 vector dot B2 vector is equals to 2 into minus 1 minus 2, 5 into 8 40, minus into plus minus 3 4 is 12, which is equals to, see here, 40 minus 2 minus 12. Minus 2 minus 12 is minus 14 plus 40, which is equals to 26. Therefore, the value of B1 vector dot B2 vector is, therefore, value of B1 vector dot B2 vector is 26. And also we need magnitude of B1 vector. Magnitude of B1 vector is equals to square root of 2 square 4 plus 5 square 25 plus minus 3 square 9, which is equals to square root of 25 plus 9 34, 34 plus 4 38. So root 38 is the magnitude of B1 vector. Similarly, magnitude of B2 vector is equals to square root of minus 1 square 1 plus 8 square 64 plus 4 square is 16, which is equals to square root of 64 plus 16 80, 80 plus 1 is 81 and square root of 81 is 9. So we got the required values B1 vector dot B2 vector, magnitude of B1 vector and magnitude of B2 vector. So use or substitute these three values in the formula. Cos theta is equals to B1 vector dot B2 vector is 26 divided by magnitude of B1 vector is root 38 into magnitude of B2 vector is 9. Therefore, theta is equals to cos inverse of 26 divided by 9 root 38 is the angle between two given lines. This question is also important, asked in your annual examination for the 2 mark. I hope all of you understood. Now let's start the next question. And the next question is, same thing here also we need to identify the angle between the lines where Cartesian equations of the lines are given. Here the value of A1 is 2, B1 is 2, C1 is 1 and A2 is 4, B2 is 1 and C2 is 8. Therefore, B1 vector, by comparing this with the standard form of lines, B1 vector is 2I plus 2J plus K and B2 vector is 4I plus J plus 8K. And we know that the angle between two lines formula, that is what? Cos theta is equals to modulus of B1 vector dot B2 vector divided by magnitude of B1 vector into magnitude of B2 vector. So we need B1 vector dot B2 vector. So B1 vector dot B2 vector is equals to 2 into 4 8 plus 2 into 1 2 plus 1 into 8 8, which is equals to 10 plus 8 18. And we need magnitude of B1 vector. So magnitude of B1 vector, square root of 2 square 4 plus 2 square 4 plus 1 square 1 is equals to root 9 and which is equals to 3. Similarly, magnitude of B2 vector is equals to square root of 4 square 16 plus 1 square 1 plus 8 square is 64, which is equals to square root of 64 plus 16, 80, 80 plus 1 is 81, which is equals to 9. Now use these three values in the formula. Therefore, cos theta is equals to modulus of b1 vector dot b2 vector is 18 divided by magnitude of b1 vector is 3 into magnitude of b2 vector is 9. So now see here I can cancel 9 ones are 9 twos are. Therefore, cos theta is equals to 2 divided by 3. Hence, angle between two lines theta is equals to cos inverse of 2 by 3. I hope all of you understood. Now let's start the next question. And the next question is find the value of P. Find the value of P so that the lines, first line and second line are right angles. In this question, he has given that first line and second line are at right angles, means they are perpendicular. And we need to identify the value of P. See here, when two lines are perpendicular, if suppose the direction ratios of first line is A1, B1, C1 and direction ratios of second line is A2, B2, C2, then the condition of perpendicularity of two lines is A1, A2 plus B1, B2 plus C1, C2 equals to 0. If any two lines are perpendicular, then the sum of product of their direction ratios definitely equal to 0. It means in this question he has given that two lines are what? Perpendicular to each other. It means A1 A2 plus B1 B2 plus C1 C2 equals to 0 already he has given in this question. If A1, A2 plus B1, B2 plus C1, C2 equals to 0, we need to identify the value of P. See here. To identify the value of P, first we need the values of A1, B1, C1 and A2, B2, C2. To obtain the values of A1, B1, C1, compare this first line. Compare this first given line with the standard equation of line. That is what? X minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 by c, where the direction ratios of first line we considered as a1, b1, c1, and compare the second line with the standard equation of line, that is what? X minus x2 divided by a2, y minus y2 divided by b2 and z minus z2 divided by c2. So after finding a1, b1, c1 and a2, b2, c2, just substitute in the given condition. Directly we got the value of p. See here. To identify the value of b1, a1 and c1, compare this first line. Compare this first given line. Compare this first given line with this first equation of line. So here the first term in the given line 1 minus x, but here in standard form x minus x1. So in the standard form coefficient of x is 1, but here coefficient of x is minus 1. So first we need to convert it in the standard form. To convert this first term in the standard form, I am going to multiply and divide this term by minus 1, or multiply both numerator and denominator by the minus 1. See here, if I multiply by minus 1 with the 1 minus x and minus 1 with the 3, for balancing we need to multiply minus 1 both numerator and denominator. See here, minus 1 into 1, minus 1, minus into minus x plus x divided by minus 1 into 3 is minus 3. So if you multiply the first term by minus 1 to its numerator and denominator, it is converted what? It is converted as x minus 1 divided by minus 3. X minus 1 divided by minus 3. X minus 1 divided by minus 3. Now this is in a standard form. Similarly, we have to convert the second term also in the standard form. We have to convert the second term. First term see here. We need to convert the second term in the standard form. Here the coefficient of y is 1, but here the coefficient of y is 7. So that's why divide both numerator and denominator by 7. See here, 7y minus 14 divided by 7, all divided by 2p divided by 7. So this can be written as 7y divided by 7 minus 14 by 7. So 7 7 get cancelled, 7 1s are 7 2s are. So numerator becomes what? Y minus 2, y minus 2 divided by 2p divided by 7. So therefore second term takes the form y minus 2 divided by 2p divided by 7. Now observe here, this second term is similar with the second term of the standard equation of line, where y1 is 2 and b1 is 2p by 7. Bariti nodri ಇಲ್ಲಿ. The value of b1 is what? 2p by 7. And similarly from the first term, a1 is minus 3. And to identify the value of c1, observe the third term in the given line. Here the third term is z minus 3 divided by 2. Already this is a similar with the standard term. So therefore no need to simplify anything here. So as it is, the third term is z minus 3 divided by 2, where the value of c1 is 2. Where the value of c1 is 2. And similarly, to identify the value of a2, b2 and c2, to identify the values of a2, b2 and c2, compare this second given line. Compare this second given line with this standard equation of the second line. So here the first term is 7 minus 7x divided by 3p. But here the first term is x minus x2 divided by e2, where the coefficient of x is plus 1 here, but here minus 7. To make it 1, we need to divide both numerator and denominator by the minus 7. ನೋಡ್ರಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, 7 minus 7x divided by minus 7 whole divided by 3p divided by minus 7. So numerator can be expressed as 7 divided by minus 7 minus 7x divided by minus 7, and denominator as it is. And see here, 7 and 7 get cancelled, it becomes minus 1, and minus into minus plus, 7 and 7 get cancelled, x divided by denominator is as it is. Therefore the first term of the second line ಏನಾಯ್ತು ನೋಡ್ರಿ, minus 1 plus x can be written as minus 1 plus x can be written as x minus 1 divided by the denominator. Denominator ನೋಡ್ರಿ ಏನದ, 3p divided by minus 7. 3p divided by minus 7. So by comparing this with the standard form of the line, we got the value of a2, where a2 is 3p by minus 7, and which is equals to, now to identify the value of b2, compare the second term in the given equation of line. Compare the second term in the given equation of line with this second term. Here the second term is y minus 5 divided by 1. So observe here, this term is similar to the standard term. So it means second term as it is y minus 5 divided by 1, where the value of b2 is 1. And similarly for c2, compare this third term with the standard form of the third term, where the third term in the given equation of line is 6 minus z divided by 5. So observe here, in the third term the coefficient of z is plus 1, but here minus 1. To make it same, multiply minus 1 to both numerator and denominator. So ಏನು ಮಾಡತ್ತೀನಿ, minus 1 ಲಿಂದ numerator ka denominator ka multiply ಮಾಡ್ತಾ ಇದ್ದೀನಿ. minus 1 into 6 minus z divided by minus 1 into 5, which is equals to minus 1 into 6 minus 6, minus into minus plus 1 into z, z divided by minus 1 into 5 is minus 5. So therefore the third term minus 6 plus z can be written as z minus 6 divided by minus 5. Now by comparing these two terms, the value of c2 is minus 5. So we got the required values a1, b1, c1 and a2, b2, c2, where a1, b1, c1 are the direction ratios of the first line, and a2, b2, c2 are the direction ratios of the second line. Now use these values in the condition of perpendicularity, that is what? A1 A2 plus B1 B2 plus C1 C2 equals to 0. The value of A1 is minus 3 into A2 is minus 3p by 7 minus 3p by 7 plus value of B1 is 2p by 7 into value of B2 is 1 plus value of C1 is 2 into value of C2 is minus 5, which is equals to 0. Now minus into minus plus 3 into 3p is 9p divided by 7 and plus 2p into 1 2p divided by 7 plus into minus minus 2 into 5 is 10 equal to 0. So 2p by 7 plus 9p by 7 is equals to 11p divided by 7 equal to e minus 10 right side shift ಮಾಡಿದ್ರೆ plus 10. So by the cross multiplication 11p is equals to 10 into 7 70. Hence the required value of p is equals to 70 divided by 11. I hope all of you understood. One of the most important question many times asked in your annual exam for the 3 mark. I hope all of you understood. Now let's start the next question. And the next question is, show that the lines first line and second line are perpendicular to each other. So this question is also similar to the previous question. In previous question he has given that two lines are perpendicular, we need to identify the value of p. But in this question we need to prove that these two lines are perpendicular. So to prove these two lines are perpendicular, we need to prove that the value of A1 A2 plus B1 B2 plus C1 C2 is equals to 0, where A1 B1 C1 are the direction ratios of first line and A2 B2 C2 are the direction ratios of second line. So observe here, the first line is x minus 5 divided by 7 equal to y plus 2 divided by minus 5 equal to z by 1. So this is already in the standard form of line, where x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1, where the value of z1 is 0. Value of z1 is 0. So therefore the direction ratios of first line, let's say a1 b1 c1, value of a1 is 7 and the value of b1 is minus 5 and the value of c1 is 1. Similarly the direction ratios of the second line, so let's say a2 b2 and c2. So see here, second line is also in the standard form, x minus x1 divided by a, y minus y1 divided by b, and z minus z1 divided by c, where a, b, c are considered as a2 b2 c2. Value of a2 is 1 and the value of b2 is 2 and the value of c2 is 3. Now to prove that these two given lines are perpendicular, so consider LHS of the condition of perpendicularity. Consider LHS of the condition of perpendicularity, that is a1 a2 plus b1 b2 plus c1 c2, where the value of a1 is 7 into a2 is 1 plus b1 is minus 5 and b2 is 2 plus c1 is 1 into c2 is 3, which is equals to 7 into 1 7 plus into minus 5 into 2 10 and plus 1 into 3 is 3. So observe here, 7 plus 3 10 minus 10 as it is, so therefore 10 minus 10 is equals to 0. Hence we got a1 a2 plus b1 b2 plus c1 c2 equals to 0. It means given two lines are perpendicular to each other. This is what we need to prove in this question. I hope all of you understood. And one more thing, this question also asked in your annual examination for the 3 mark, one of the important question.